Hey everyone, welcome to day number 3 of TryHackMe's Advent of Cyber 2024 edition. And I'm so excited for today because today's task is awesome. We are going to be looking at a specific attack technique from the defensive side of things, but also from an attacker's perspective. So enough with the intro, let's just hop on the computer and see what TryHackMe has been preparing for us. Alright, so we are here at the start of our task for today, but the first thing that we are going to do is set up our environment. So let us do that together. If you scroll down a little bit, you will see on this image the things that we will need for our task today. So we will need to start the attack box and also a virtual machine. This virtual machine will be our target machine, and the attack box is where we are going to execute all the tasks. So for the virtual machine, we can click on this big green button here on the left. There we go. And if you scroll all the way up, you will see that within a minute or so, you will get an IP address for this target machine. Now, when it comes to the attack box, you can just click on this button here on the left that says Start Attack Box. Let us click on that. And now this will take like 1 minute or two. So let us give it time and get back to it once everything is online. And there we go, with the magic of video editing that took less than a second. Now we need to do two quick things. Because this is not very practical, I mean, if I do anything on the right side of my screen, my head will always get in the way, and we don't want that. So what you guys can do is you can click on this View in Full Screen button here on the bottom. And that will open a new tab with the virtual machine, I mean the attack box, in full screen. So now we can do fun stuff. Let me just close this terminal. And if you go back, you don't have to have this split view right here. So you can just click on this minus sign right here in the bottom. And there we go. Everything is ready now. You can see that the target IP for the target machine is right here. And we also have our attack box ready to go. So let us just now scroll back to our task and start by reading the story. But before we do, let me just give you a little disclaimer. Because I don't want this video to turn out like a Lord of the Rings movie, 3 hours long, and I actually want it to be as engaging as possible, I'm going to be skipping a lot of the reading parts. So I highly encourage you to read the entire thing, but for this particular walkthrough, I'm going to do my best to explain you all the concepts and all the tools that you need to use to solve this particular task by using my own words and by following up with the examples that TryHackMe is providing, not necessarily just by reading the entire thing. So that is the disclaimer. Let us now finally start our task for today. So we have a little poem here, and right off the bat, I'm going to skip this first part. First, because I'm terrible at reading poems, and second, because the juicy hints and the juicy information are within these two sections right here. So I'm going to read those for you. Just as he was ready, the glitch got a fright. An RCE vulnerability on their website? He exploited it quick and made a report. But before he could send, arrived this transport. In the Frosty Pine sock, they saw an alert. This looked quite bad. They called an expert. The request came from a room, but they couldn't tell which. The log saved the day. It was the room of the glitch. So we kind of got some very insightful hints here. So we have a remote code execution vulnerability. By the way, if you don't understand some of the acronyms, and yeah, this is something that we have to deal a lot in the IT and cybersecurity world. Acronyms, everybody loves them. Actually not, but you can just click on them and TryHackMe gives you a definition on everything. So for SOC, for example, Security Operations Center, you can click on the term and it will give you a definition on what it is. Same for RCE, once again, remote code execution. So yeah, this is very exciting. And as I told you in the intro, this is going to be a very special task because we will be performing a purple team engagement, actually. We will be going through the defensive side of things and offensive side of things as well. So when the blue team and the red team work together, we have a purple team exercise, which is why if you have a keen eye, you would have seen that log analysis is in purple, not in blue and not in red, but the combination of both. I digress. Let's move forward because we have a lot of stuff to cover today. So first things first, we have some learning objectives. We are going to learn about log analysis. We are going to be learning about KQL, which stands for Kibana Query Language. It's the language that we are going to use to do search queries on the logs for log analysis. And then the tool that we are going to use is part of the ELK stack. Now, if you click on this, ELK stands for Elasticsearch, Logstash, and Kibana. These are 3 open source tools that help you collect, store, and analyze logs. And the one that we are going to use specifically is Kibana, so the Kibana dashboard. And finally, we are going to learn, like the poem mentioned, we are going to learn about remote code execution and how it can be exploited via insecure file upload. So this is the vulnerability that we are going to exploit in order to obtain remote code execution. Again, this is the offensive security part, so red team, and these two are defensive security, and so blue team. All right, so we don't need to worry about our setup and our environment. We already took care of that. So if we go, we will see that we are going to start with the blue team, the defensive side of things first. And so log analysis is our first task. Now, as I said before, we are going to be using Kibana from the Elk stack. And if you're interested in learning more about this, TryHackMe actually has a room where you can investigate with this stack. So you can follow this link, and after the task, maybe you can dive a little deeper into what these tools are all about. But now we are going to look at what the tool actually looks like. So the first thing that I'm going to do is I'm just going to copy this URL. I'm going to go to our attack box. I'm going to open the browser. Awesome. Now we can paste the URL right here and we can press enter. There we go. We have access to the tool. Awesome. So now what will happen is we will learn how to use the tool, what type of filters we can use, how we can perform log analysis. So let us do that. The first thing we need to do is we need to click on these 3 lines and then select discovery in order to start our log analysis. After that, we need to select the log collection that we want to analyze. So for this example, we are analyzing the Wareville Rails log collection. Then, if you follow along and you actually replicate all of these steps in your attack box, and the reason why I'm telling this is because you actually can. So just to show you, if you click on the 3 lines and click on discover, you will see that if you go and want to select the Wareville Rails log collection, you can, and you will be able to actually replicate the exact same steps that we are following along within the task example. The reason I'm not doing it, replicating all the steps, it's just to save time. Now here you saw that when I click on this log collection, the Wareville Rails, you see that there are no results for this search criteria. Now why is that? Let's go back to the task and see why that is happening. It's basically because we haven't defined any filters. So one filter that is very, very useful for log analysis is the date and time filter. So you can select a date and a specific time, and then you will be able to analyze all the activity that occurred during that time interval. Now let's look at Kibana's user interface. So you will see there are a couple components here on the main dashboard, and I'll tell you what those are for. So number one, we have a search bar. This is where we are going to type our queries using Kibana query language. Then the second component is where we choose the log collection. We already showcased that. Number 3, we have different fields, and here we can specify or nail down our search and investigation to different IPs, for example, or any other of the fields that we have here. Then number 4, we have a timeline, so we can see the time interval that we selected. On the number 6, actually, this number 6 will be where we define the dates. And number 5, going back one number, is where you actually have the logs and all the data, all the documents. So then we have our first example using Kibana query language. The example is pretty simple. So if we want to analyze all the data that has this IP address, we can search for ip.address : and then we type the IP address inside of double quotes. Awesome. And then TryHackMe kindly provides us with a small cheat sheet for other syntax that you can use for the KQL language. So we have double quotes, the asterisk for wildcards, you have the OR and AND operators, and finally the column. Now let's dive into the investigation part, shall we? So the first thing that we need to do, of course, again, is to select the log collection that we want to investigate in. We've already seen that we are going to use the Wareville Rails, and then we need to define the date filters, which in this case is going to be October 1st, 2024 and October 2nd, 2024. So we do that, we click on update, and then after that, we will see the logs now in our main dashboard. Now, another thing that you can do is if you click on the client IP field and then on the plus sign in any given IP address, you can isolate all the traffic that corresponds to that IP address. So that removes a lot of the noise. We had like 1,000 hits, and just by isolating the traffic to that specific IP, we got 400 and something. So that is very useful. Then if you need to remove filters, you can just click on the X. And now for this investigation in particular, we are going to focus on this particular IP. So the the one that ends in 230. So what we need to do is, again, click on the client IP field and isolate it by click on the plus sign right here that is associated with the IP that we want to isolate. So when we do that, we remove a lot of the noise from the logs, and now we can start our analysis. Another thing that you can also do, if you want to get additional information for each one of these log entries, you can click on this greater than sign that is right here, and it will give you a lot of additional information about that specific log entry. All right, so after some digging on this example, we found some things that were interesting. So in these requests, we can see that a file named shell.php has been accessed with a few parameters C and D, and we can see those here after the shell.php file. And after those parameters, both C and D, we can see that someone is trying to execute a command dir. And the command dir serves to list the files that are present in a folder in a Windows system. So that is interesting. Someone is trying to get the server to execute a web shell so then they can execute commands on the server. Nice. Now that we have an initial lead, let's use a search query to find all the logs that contain shell.php. Now, this is the first example where we are actually going to use KQL on the investigation. The last example we had was where we were trying to search for a specific IP address. Now we are searching for a specific string. So we are using the field message, and then we are searching inside of double quotes shell.php. And you'll be able to see that all of the requests that have that file are right here. So that was the example for the log analysis part. Now we are going to jump into the offensive security side of things. So we just covered the web shell and remote code execution attack from a defender's perspective. We went through the logs, we saw what was happening. Someone is requesting a shell script and then they are executing commands on the server. Now we are going to look how an attacker would perform such an attack, and then we will actually get the chance to do that attack ourselves. So that is very exciting. Let us do that. Before we do it, we will need to go through some key concepts. And the first one is, why do even websites allow file uploads to happen? Think about social media, for example. You want to upload your profile picture. If you have a YouTube channel like I have, you want to upload your videos so you can interact with your audience and share your work. Now, the problem is when those applications don't have any filters or any validation on those file uploads. So for example, if you're trying to upload your profile picture, you're probably uploading a JPEG file or a PNG file and not an executable file or a PHP file with code inside it, right? So what happens is, if the applications are not doing any validation, the attackers might do some malicious activity by leveraging that insecure file upload vulnerability. Now we have two examples of vulnerabilities right here. First, remote code execution, we've been talking about it. Uploading a script that the server runs, and then it gives the attacker control over that same server, because then the attacker will be able to execute commands on the server. Then we also have XSS, which stands for cross-site scripting, and this can happen when you upload an HTML file that contains a malicious cross-site scripting payload or code, which will steal cookies and then send those back to an attacker's server. So imagine you can steal someone's legitimate session cookies, and then you can impersonate that user, for example, and extract information and do damage on behalf of that user. So this is serious stuff, right? So yeah, we just went over why unrestricted file uploads are dangerous. But then another thing that attackers might try to take advantage from is the usage of weak credentials, or even worse, default credentials. And I've seen a lot of this in the real world, like real enterprise environments where people deploy their systems, their appliances, and they forget to change default credentials. And in some manuals and service providers, those default credentials are well known. And we have a couple examples here. So you probably have heard about the one that has admin or admin password as default. So here we even have an example for guest accounts where you have guest and then guest as a password as well. So this is actually pretty common. Don't think it isn't. So it's very nice that TryHackMe references that here. Now, we've been talking a lot about remote code execution. Now, according to TryHackMe, this happens when an attacker finds a way to run their own code on a system. This is a highly dangerous vulnerability because it can allow the attacker to take control of the system, exfiltrate sensitive data, or compromise other connected systems. And how are we going to get to the stage of having remote code execution on a server? Well, for today, we are going to use a web shell. A web shell is basically a script that attackers will try to upload into a server, and if they manage to get the server to execute that script, they will then be able to execute commands on that same server. Now, how do you do that? As it says here, practice makes perfect. Let's try to analyze how an attacker would actually perform the attack with a real-life example. So here we have an example of a web shell. This is a PHP file that we have here. It has HTML code, it has PHP code, but I'm going to try to explain you how this works. So if you would copy all of this code and save it as a file, for example, shell.php, as we've seen on the example where we were doing the log analysis, what happens is if the web server executes that script, then it will generate a web page with a form inside of it. Then that form will have two input fields. It will have a text box for you to type your commands, and the other input will be a button for you to click and execute those commands. And then, if the command is executed, then the system will output the response to that command on that same web page. We also have this HTML tag here, pre, which stands for pre-formatted text. I think I'm getting that right. And what that does, basically, it outputs the text with all the spaces and all the line breaks like as it is. It's not going to alter any of the output of the commands. So yeah, then what an attacker would do is that the attacker would try to find a website that has input field where you could upload files. And in this example, we are in a page where you're supposed to apply your profile picture. So you would accept JPEGs and PNGs and other image formats, but not a PHP file with code in it. It doesn't make sense, right? But in this specific case, we were able to get success. And so then when the attacker is able to upload the script, what happens is the attacker will try to figure out in which path or directory is the server storing the script. And then when the attacker is able to find that information, he will try to access the script directly by typing in the URL and then the path to the script. Then he will press enter, the script will be executed if everything goes well for the attacker, of course. And then remember what I told you about the code? You will get two input fields. You have a text box for you to type your commands and a button for you to click and execute. And then if you type a command, in this example, you can see both in the URL, command equals pwd, which stands for print working directory. And then you have the same PhD command here on the text that TryHackMe provides. And you will see that the output is the folder where the shell.php script is being stored. So it worked. Now the attacker is able to run commands on the server. Now, in order for you to make the most out of it, you're not just going to want to print the current working directory. You want to get all the information that you get from that web server. So there are a couple commands that you can use. Some of the most used are the ls command, which stands for list. So if you want to see what files are in that specific directory, you can use this command. UMI is also very well known if you just want to see what kind of permissions you have. If you get root, then you have full control on the server pretty much. Then, as an example, we also have this command here to start a reverse shell via bash. And we also have an example to start a reverse shell with netcat. Now, main differences between a reverse shell and a web shell, just for you to know. A reverse shell starts the connection on the target and then it connects back to the attacker's system. On the other hand, the web shell is just running on the web server. So yeah, that was the theory behind the attack and how the attack works from the attacker's perspective. Now we finally have the practical stage of this task for today. We are now going to do the log analysis ourselves and also replicating the same exact attack, trying to exploit an insecure file upload vulnerability so then we can have remote code execution on a web server. So let's read this. Your task for today is twofold. First, you must access Kibana, we already did, to investigate the attack and answer the blue questions below. Alright, so this will be the defensive side of our task for today. Then you will proceed to Frosty Pines Resort's website at frostypines.thm and recreate the attack to answer the red questions and inform the developers what element of the website was vulnerable. So this is the offensive security side of our task for today. Now let us see what we have to do in order to proceed with the task. To review the logs of the attack on Frosty Pines Resorts, make sure you select the Frosty Pines Resorts log collection. Alright, so we are changing from the Wareville Rails log collection that we saw in the example, and we are now choosing the Frosty Pines Resorts. Alright. And the date and time you need to use when reviewing the logs will be between 11:30 and 12 on October 3rd. Alright. Then please note you will need to add this IP address and this URL to the hosts file to access the Hotel Management System's web app. All right, no problem. Let's start with the log analysis part. So if we go to our attack box and we full screen this once again, let us change the log collection to the Frosty Pines Resort. And now we have to change the dates. So I'm going to put October 3rd right here and 11:30, right? And then it's October 3rd once again, but now it's 12 p.m. Let us do that. There we go. We click on update and there we go. We get a lot of data right here. Now, the thing is, instead of just scrolling down and see a lot of data, we probably have to narrow our search. So to do that, let us read the questions first and try to understand what we are really looking for, shall we? So for the blue side of things, the questions are, where was the web shell uploaded to? So we are looking for 3 directory names and then a file.php, all right? And then the second question is, what IP address accessed the web shell? Let me just check the hints just for fun, shall we? Let me click on this. So for the first hint is that images are stored here. Okay, so one of these directory names must be image. And then for the second hint right here, filter the IP values in ELK to determine their activity. Only one of them is malicious. All right, so there are 2 IP addresses, but only one of them is malicious. So we have to analyze what type of interaction is occurring with the web shell script. All right, so the first thing that we are going to do is trying to find the file path where the shell script was uploaded. The way I'm going to do it is I'm going to use the Kibana query language. So I'm going to type message, colon, and then on quotes, I'm going to search for shell.php because I'm pretty sure they probably use the same name. So let us do that. And we got a lot of results, which is awesome. So now what I will do is I'm going to click on the client IP down here. Let me zoom in so you can see it better. So client IP, and yeah, we can see that we have 2 IP addresses, one of which barely interacted with our shell, or it doesn't have a lot of activity. So let me click on the plus sign right here and see what did this guy do with our shell. I just have to move my face out of the way. Now we can see it much better. So we can see that there was a GET request and someone just tried to access the file, which is not malicious by any means. No one is trying to run any commands or getting access to any files or just navigating through the file system on the server. So I'm going to put my face back where it was. And now I'm going to remove this filter right here on the left because this IP address was not doing anything malicious. And I'm going to select the other one that ends in 34. So I'm going to click on the plus sign and I'm going to take my face out of the way once again. And now we can see that this one is actually executing commands. Do you see it? It's executing the ls command to list the files. Yeah, running the id command. Yeah, this one is the one that is malicious. That is for sure. So I think we got the answer to both questions in just one go, right? I think we did. So let me just copy the file path for the shell.php file first. Let's go back to our task. Let me copy this file path right here and submit. Boom, there we go. That was right. The next one, what IP address accessed the web shell? So 2 IP addresses actually access the web shell, but according to our hint, only one of them is malicious. And it's clearly the second one. It's clearly this guy right here, the one that ends in 34. So let me paste that as well right here, submit, and there we go. We got the right answer. So we are done with the log analysis part of things. We just went through this attack from a defensive security perspective. Now we are going to change things a bit and get into the attacker's mindset. Now remember, there was a prerequisite for us to do the offensive task. We need to add this line to our hosts file. And the way I'm going to do it is I'm going to open a terminal right here. And I'm going to make it bigger so you guys can see what I am typing. And I'm going to execute this command, so nano. And I want to edit a file that is inside the etc folder called hosts. If I click enter, this is the file right here. Now, if we go down and we give ourselves a couple extra lines and we paste this line, now we will be able to navigate to that web portal. So now we just have to type Control X. We click on Y to save our changes and enter to keep the same name. And there we go. There was another way to do this. If you wanted, you could go into the file system. You basically have to go into the main file system. You go into the etc folder. You look for the hosts file and then you edit the text manually there. But for my command line lovers, that's how you do it. So yeah, let's try to access the website, shall we? I think we had the URL up here. There we go. Bam. We copy this. Let's make this full screen once again. Yes. So now we have our website. So how can we upload a file here? Let's take a look into the web pages that we have. So I don't see any file uploads on the home page. Let's go to rooms. No file upload here as well. Reservations. Yeah, you have to log in. So we don't have an account here, but if you remember, there was something that attackers leverage when they're trying to compromise websites, and that is default credentials. So if we go back up, we can see that there are a couple examples that we might try. So what is the website requesting? It's requesting an email and a password. Do we have any examples of emails here? We have one with admin at and then the domain name. So let us try that. What is the password that we might try? So admin as well, as you can see here. So let's copy and paste admin at, and then what is the domain name? It's frostypines.thm. So frostypines.thm. And then for password, let's type admin. Let's see what happens. And there we go. It looks like we have admin access to the website. So now if we go into the admin portal, yes, we have an admin console, which is great. We already navigated to the rooms page as a guest user, so not even logged in, there wasn't anything there. Oh, but you can see here, there is a way to add a new room. And there we go. There's a file upload input field right here. So maybe we can leverage this to upload our shell script and maybe get remote code execution. So let us try that. So you can be creative here. I'm just going to, of course, use 1337 as the room number. For the room name, I'm going to call it remote code execution. A very friendly name. And then what we need to do next is we need to craft our web shell script. So let us go back to TryHackMe and let us use the same example they used. Let's copy this. And now, once again, there are two ways that we can do this. You can use a text editor manually, like Sublime, for example. And then you could just paste the code right here, save the file as, I don't know, rce.php. So this is my first example. I'm going to save this on the desktop. So you'll see that our PHP shell is right here. But the way I like to do this is by using the command line. And if we go back to our terminal, and again, let me make it bigger. Let me change directory, so cd change directory to the desktop folder so we can save it on the same folder. Right now we can use nano as our text editor, and now let's create a file called shell.php. There we go. So now if we copy the same code right here, you will see that the same code is right here on this file. We can press Ctrl X and say yes to save changes and click enter, and you will see that the file will appear on the desktop as well. So you can do it with the command line and with the normal text editor where you have a user interface. It doesn't really matter. I just wanted to show you that you can do it both ways. And now let's upload our shell. So we go into the desktop and you can see that, yeah, all supported files. Of course, our PHP files do not show up here. They would show up if they were like PNG files or JPEGs, because this is supposed to be an image for this specific room. But if we click on all files, sorry, my head is in the way. If we click on all files right here, and if we select every single one of these is the same, I'm just going to select the shell.php because we are more used to that name. And we click on add room. There we go. There's our room. Yes. Look, there's our ID. The room is called remote code execution, but unfortunately we don't have an image for it because our script is not an image. Now, what was the question again? So if I scroll down a little bit, just to see what was the question for red, what is the contents of the flag.txt? Alright, so in order for us to get access to a file, we need to be able to execute commands. In order for us to execute commands, we need our web shell to be executed by the server first. And how do we do that? If you remember, if we go back, the only way to get the web shell to be executed by the server is if we know where the web shell script is being stored by the server. Then we can try to connect to that specific path. The web server is going to execute our script, and then we will get the input fields where we can execute our commands. I hope that was clear. So here's how we are going to do it. I'm going to press F12 to have access to the development tools. And then I'm going to select network right here, and I'm going to zoom in on this. I want to make it bigger so you guys can read it. Now I'm going to refresh my page, and there's going to be a ton of requests right here because there are a lot of information that is being requested to the web server. We have text, we have a table, we have all of these images, but something that we also have right here is our web shell, even though it's not visible. So let's look for it. You can see it, it's right here. And now here on the right, you will see that we actually have the information of where this file is being stored. So let us try to access it directly and see if the server actually executes our shell. And I just lost the domain name, sorry about that. So we need to only add the path right here after the domain name. Now, fingers crossed. Let's go. Oh, I need one hand to press enter. There we go. We got our web shell working. So now we can execute commands. Now remember, we are trying to find the contents of the flag.txt file. So that's a file. One command that we can use to list files is the command ls, like we saw right here on the top. Where is it? There we go. Command ls will give you an idea of what files and directories surround you. Let's use that command to see what files we have. And there we go. There's our file right there. And I'm going to teach you a secret. That was not on the cheat sheet that TryHackMe provided us, so it's not here. But the way you get the output of a text file is by using the command cat. So if you do cat flag.txt and you execute it, you will get the flag right there. So we just need to copy this, submit into our final answer, and there we go. We got it done, guys. Great job. And that was it for today, guys. I really hope you guys enjoyed this walkthrough. Take care, and I'll see you in the next one. Bye.